You know what I'm talking about? That absolute rat's nest of cables behind your desk or your TV. We've all got one. But what if I told you that mess actually tells a story? Yeah, it's a story of how we went from a whole bunch of confusing plugs to one simple connector. And it all boils down to the physics of sending information. So let's untangle this mystery together.
I mean, some of us definitely remember these things, right? These big, chunky connectors with all their pins, you had to screw them in. And now everything seems to run on this simple little USB. So what happened? What drove this massive change? Well, to get it, we have to look at how these cables are actually sending information one tiny little piece at a time.
You know, the key to this entire story is just one word: serial. Now, I know, it sounds super technical, but the idea is actually incredibly simple, and it's the secret sauce behind almost every cable we use, including the one that's probably charging your phone right this second.
So what is serial communication? It's pretty much exactly what it sounds like. It's sending data in a series. Just imagine a single file line of information, with every single 1 and 0 marching down the wire, one right after the other. That's it, that's the whole concept. Okay, here's a really easy way to picture the difference. Think of serial as a single-lane road, just one bit at a time. The other way to do it, parallel communication, that's like a massive multi-lane highway, sending whole groups of bits all at once. Now you'd think the highway is always going to be better, right? More lanes, more data. But it turns out that at really high speeds, the signals in those parallel lanes can start to interfere with each other. It's like cars drifting and causing total chaos. That simple single lane, though, it turned out to be way more reliable and ultimately faster because you can just crank up the speed without all that interference.
All right, so let's hop in the time machine for a second. Before our world of simple, standardized plugs, there was this whole family of specialized serial connectors, and each one had its own unique and sometimes confusing purpose.
Meet RS-232. Back in the day, this thing was a huge deal. Its main job was to create a solid, reliable link between a computer and something like a modem. Yeah, you can think of it as the workhorse of early internet, that beautiful dial-up sound.
Now these RS-232 devices used connectors that looked like this one, the DB25. And get this, the name itself is basically a secret code. The D is for its D shape, B is for the size of the outer shell, and 25 tells you it has 25 pins. Every single part had a specific meaning, which really just drives home how non-universal these connections were.
So here's the bottom line. They're gone. You just don't see these ports on modern machines anymore. It was pretty clear the world needed something simpler, way more flexible, and truly universal. And that, of course, brings us to the hero of our story, the Universal Serial Bus, or as we all know it and love it, USB. This was the technology that finally came in and cleaned up that cable mess for good. What USB did was take that one bit at a time serial idea and just supercharge it. It really quickly became the default built-in connection on pretty much every single computer, and it offered a level of flexibility that those old ports could only dream about. And just how flexible are we talking? Well, a single USB port on your computer can, in theory, handle up to 127 different devices. 127. Now, you're probably never going to actually connect that many things, but it just shows you the incredible power and scalability of this standard.
And of course, we see that flexibility every single day. Printers, scanners, keyboards, mice, joysticks, you name it. USB became the one port to rule them all, right? It replaced a dozen different specialized connectors with one simple plug that just works.
Okay, so we've covered the history. We went from these clunky, specialized connectors to the elegant universal USB. But if USB is so great, why does it have limits? And that's where we make a little pivot, from history to physics.
This right here is the big question. If USB is so awesome, why isn't everything just USB? Why do office buildings, data centers, and the internet itself still depend on a whole different family of cables, like that classic Ethernet cable you plug into your router? Well, the answer comes down to two really fundamental trade-offs that control any signal that's traveling down a wire. You've got speed and you've got distance. So first, let's talk speed. Think about the network in an office building. The main data highway, the one in the server room. It needs to be unbelievably fast. We're talking 10 gigabits per second, maybe even more. But the connection running to your individual desk, it doesn't need anywhere near that kind of horsepower. Different jobs need different tools, and in networking, that means different cables. Okay, But the second, and honestly the more important factor, is something called attenuation. You can think of this as the natural enemy of any signal. As your data is zipping down a wire, the signal gets weaker and weaker. It's just like how a voice fades out over a long distance. And the problem is, as that signal weakens, it gets harder and harder for the other end to tell the difference between your actual data and just random background electronic noise. And that's when you start getting errors.
And this isn't just theory. It has very real-world consequences. A standard Ethernet cable has a maximum effective length of about 328 feet or 100 meters. If you try to go beyond that, attenuation wins. The signal just degrades so much that your data gets lost. This is exactly why you can't just buy a 500-foot USB cable, run it across your house, and expect it to work.
So let's just quickly recap the journey we've been on. We saw the evolution from that whole mess of specialized connectors to the simple universal USB. But we've also discovered that even USB can't beat physics. When you're talking about the high-speed, long-distance needs of the internet, the fundamental limits of speed and signal loss mean you still need specialized tools for the job.
And this all leaves us with a really fascinating question to think about. We are always pushing for more speed over longer and longer distances. So, what comes next? Are we going to see some new standard that combines the incredible convenience of USB with the raw power of something like fiber optics? The story of the liars behind our screens, well, it's far from over. Thanks for joining me on this one.